I'm giving like a way to interact with the triangles that exist in a map BSP using SAPP. And so the first thing you have to do is like find a way to get access to a model of the map that you want to write a script for. I'm using Eschaton, and they have a wavefront object exporter where you can just export the entire BSP to a wavefront object file. And I'm just showing that process right now. And I'm using Blood Gulch just because it's familiar and it's easy to remember. So like I did this on Windows because I couldn't get the Linux version of Eschaton working, but all I did was extract the BSP to an object file, and then so now I'm like importing it into Blender so that we can access all of the model information and do things with it. So in Halo, the Z direction is up and down. So whenever you have a model, it's rotated by 90 degrees on the x-axis, and that makes it difficult to work with in Blender. So I just end up rotating it to 0 just to make it easier to work with. There's probably some configuration in Blender where you can change that, but so you can really, for the purposes of this example, I'm just going to use something basic, but you can really write an interaction with any triangles, but you have to keep in mind that the cost, like the CPU execution cost, is going to increase with the number of triangles that you write your interaction with. So for the purposes of this example, I'm just going to be using like red base and the little ramps that lead up to the red base. And so I have those selected. And what you want to do is get rid of everything else. So you invert whatever you've selected and delete everything else. And then I'm rotating it back to where it should be using the Halo coordinate system. So then when you export this to a wavefront object, it only contains like a few triangles that need to loop over in the code once I get to that. So I've written this little JavaScript thing that takes a wavefront object syntax and will return a Lua array of those triangles. And if you want to look up wavefront object syntax, it's kind of simple. So it wasn't too difficult to write something to parse this. So I'm going to save this as a new file, but I've created it before for the purposes of walking myself through this a couple times. And you want to save it to the Halo server root directory, like the same location as halodev.exe, or, you know, where the maps folder is and stuff like that. So you're requiring the file of whatever you saved it as, and that allows you to loop over those triangles within the SAPP script. So yeah, this is a bunch of math that I don't understand that ChatGPT was able to write for me, and it's ray triangle intersection, and you supply it with the starting point in 3D space, which I'm setting as object X chord, object Y chord, object Z chord, and you also supply it with a ray, which is a normalized vector, it's basically just like you're pointing from a direction somewhere in 3D space. And the third parameter is just the triangle. So for the purposes of this, I'm doing a vector that goes straight down from the player position so that we can see, like, is a player standing on this triangle? But really, it's just, is the triangle below the player? And these object X, Y, and Z chord, I'm just getting the player position. And the second loop that's up there, that's commented out, I'll get to that later. It's just for if you wanted to do, like, if you had two pieces of the map that were above and below each other, then you want to, and you wanted to know which one they were on, and you have to loop through them one after the other. And so I'm going to go ahead and run the Halo server with this script loaded. So when the player is standing on a triangle, it should tell us that they're, I mean, not technically standing, but just, you know, if their position is over it. And this can be pretty precise. It's like you can. There are edge cases which I'll go into later in this video, but it's very precise in the measurement of, like, where you are in relation. So here's an example of, like, you're technically not on the ramp, but you're above it. So you're on another piece of the map. But this example is just like, you could determine where a player is or something like that, but you could use any point and any vector of any other object or thing in the game and write some kind of interaction based on that. So now I'm going to get the triangles that are above the ramp and extract those. I mean, you know, make another Lua array of those triangles only in another file. And for some reason, I recorded this video twice, and for some reason, it was just like, when you require files in Lua, I'm not sure what their convention is, but I had to change some things where it's like, you have to return the triangles, like here I'm returning the variable triangles. For some reason I had to do, like, triangles too. Like, I don't know the scope of things that you require in Lua. Like, within the actual, in this file, yeah, I had to do this for it to work properly. So now we know in that above ramps variable, that Boolean, it's just like, are we above the ramps? And then, you know, if you are, then do something else. And if you're not, then you're on the ramp, but you're not above it. So in the way that you can walk on surfaces in Halo, you can really kind of stand where there is no actual ground where you should be standing. So, like, if you stand on the very edge of, like, a surface that goes straight down like the edge, you're still technically going to be above that triangle, but you're not actually standing on it or anything. So what I'm going into, eventually I'm going to, like, shorten the ramp on both sides in Blender. Yeah, so it's literally an edge case that you're not even on the ramp, but it's going to still be detected that way because the player position is over the top of it. So I'm going to, like, you know, just shorten the ramp on both sides in Blender so that hopefully you get to, like, the center of the player model, but not to the edge of where you'd be standing on nothing. I don't know if that makes any sense, but if you don't really care about that, you can just uh that's the end of the video, and it doesn't really matter, if you're not a perfectionist about this and you don't really care about that type of thing. But I'm going to attempt to, make a very perfect like model type thing where, I mean, you're technically just editing what was in existence that someone else made a long time ago just to fit your needs. And this is going to be different for everything that you wanted to do. Like you're just gonna have to logically think through uh, the edges of whatever you're interacting with. It's like for this, you just need to shrink the width of the ramp, I guess, by like a certain amount, just so that when you're standing on the edge, you're not going to be over it. So another thing you could do is you could just simply export all of the triangles in your map and loop over those to perform something. That is very expensive because even like I'm just attempting to learn about some of these 3D things, and looping over all the triangles in an entire map is probably a bad idea. But you could do it like if you wanted to take the player's aim as the vector input, and the point that you put into it could be like the player's camera. And you could say, I'm aiming at this very specific point on the map, but I'm not exactly sure of how to get the closest, well, I guess you could get the closest point to the player that intersects with those triangles, and then that's um, like where they're aiming on the map. Otherwise, if you did that, you would end up with a bunch of points, like if there were multiple different triangles that you were trying to, that it was intersecting with. Um, Another thing that I did was I would draw a cylinder of sorts. I guess it's just like a 3D circle, and all of the vector things of the circle would be pointing straight down. So right here, I'm getting very close to being able to get off the edge, but like there's this thing where if you go all the way up against the wall, it's not detecting you. So I have to increase the width by a tiny amount again. But anyway, so like I forgot what I was talking about. Um, oh yeah, so like I was making like a 3D cylinder, and kind of like making equidistant points around that cylinder, and the vectors would point straight down. So, and the triangles that I was interacting with were all of the triangles that made up surfaces that you could technically walk on. So you choose a point and draw a cylinder of equidistant points, and then you could spawn an item that made a circle on the ground. So like you could spawn a circle of health packs or overshields or something around a specific point, and they would always be, at the position on the ground where they're supposed to be. They won't be like floating above it for a few seconds or whatever. Um, because like if you take the ground is very like, it's not always going to be like a completely flat surface. Yeah, and this is just me fumbling through this where it's like I think I forgot to rotate it 90 degrees or whatever. But in the end, it probably works to a good degree. That's like most people are going to say that's acceptable. Where It won't detect you if you're off the edge, but it will detect you if you're... Yeah, so I forgot to rotate it 90 degrees, but whatever. I'll go back in and eventually realize my mistake. So all of these files are in the description if you haven't already checked for them. I'm not exactly sure. I'll just find the things that I didn't make and try to find original links to them. So now, if, yeah, it's an acceptable level of error. If you wanted to write some kind, like, what if whenever you walked on the ramp, your health started regenerating or something like that, or whenever you walked on the ramp, something happened in the game. I don't know. Just pick anything. Like whenever you walked on the ramp, you teleported somewhere else or something like that. I don't know. Just the fact that that text is appearing means that you can control what happens on that ramp. But anyway, I think this is nearing the end of the video. Thanks for watching, and I will include all the code that I use and stuff so that you won't have to do anything crazy like that.